Okay, so for those of you who are here, who has questions? Okay, I don't know if you guys noticed, but I did upload your first project. Did you guys see that up in e-learning? Okay, so I'm going to share my screen just to make sure everybody found that. Here's our e-learning site. If you go to, what happened here? I thought I put an update about it, but obviously I didn't put the update announcement in there yet. I will add that. But your project is here. You should be able to find it in activities and then go to assignments. And then it's right here, project number 1, linear modeling. So if you click on that, from my point of view, I just see the submission. So I'm going to see who submitted things, and obviously nobody has done so yet. You're going to see the project document here. I'm not sure why I can't see that at this point. I'm going to actually view as students so you guys can see this from a student standpoint. I think that'll be better. It's taking a minute. Okay, so here we go. We're going to go to I'm sorry, not content, but activities. So we'll have to jump over there. Activities and then assignments. And then you'll see project number 1, linear modeling. And now you guys are going to see the attachments. So the first 2 attachments are actually the same thing, just in 2 different formats. So one is a PDF format and the other is a Word document. You can use either one, but either way, you're probably going to want to print that out just so you have handy reference. If you don't have a printout, it's not absolutely necessary, or a printer, because you can read through the instructions and then work through the problems there. Then the next 2 documents, again, are the same thing, 2 different formats. One is an Excel spreadsheet, so you could use that for really any kind of computer, but if you do have a Mac, I created this on a Mac, so the numbers formatted spreadsheet is at the bottom. So that's where you're going to get the data for your project. And so you're going to use one of the first 2 and one of the last 2. It is due on Sunday, the 25th. So that's, I think a week later than, or a few days later than what the original due date said. Yeah, it's a week later. It was originally set to be due the 18th, but I didn't want to pressure you this week to have to try to crunch it all in. So it'll be due next week, the next Sunday. So that you've got about 11 days, I think. Today's the 14th, right? 12 if you count yesterday when it was there. But I will also add an announcement on the announcement page so that you can find it with ease that way as well, with some more details on information for it. Notice if I click on it, I get more information about it. When you get done, you're going to save it as a single PDF document. This is really important. One document. I don't want you to put 3 documents up. So everything that you create, you need to get into one document and then save as PDF. And then you'll be able to upload it to the assignment folder. So when you're ready to submit, you just add your file and go ahead and submit it. Do you guys have any questions on that right now? And you might not until you have a chance to take a peek at it and start working on it, but it's there for you. Any other questions? Other questions about things going on in class, where you are, what you're working on? Maybe specific homework questions or maybe more general questions? Okay, so let's do just a quick check-in then. If you guys can type in chat and let me know where you are in homework. And you don't have to give section numbers or anything like that because they're a little bit different between Alta and between the textbook anyway, but just sort of let me know what topic you're working on right now. Zach, is that a nope that you don't have any questions, or nope, you're not going to tell me what you're working on? Okay, good. I figured so. Ashley, do you have any questions today? Do you guys want me to move on to new things and give you sort of an overview of what comes next, or do you want to wait and see if you have questions and work on stuff today? It's up to you. I sure can, Ashley. So last time, I don't remember if you were here last time. I'm thinking you weren't. So last time I did an overview of polynomial functions and adding, subtracting, multiplying, and dividing. So if you didn't go back and listen to that recording, you might want to do that. And so what's coming next beyond that is going to be dealing with factoring polynomial expressions. So essentially sort of doing the reverse of the operations and going back to the factored form. So you guys probably remember doing a little bit with factoring at some point or another. Yeah, I bet you have. So this is going to sort of take us back. Before I do that, I'm going to do a little bit of review of multiplication in some special products because those are going to come up in our factoring stuff. So let's see, we'll share from here. Okay, and there we are. Okay, so let's see. Just a reminder of multiplication, and it makes sense why I want to, and we'll do this pretty quickly because if you need details, again, you can go back to the recording from last time, from Monday. So multiplication essentially uses the distributive property, and it uses it a couple of ways. So if you had a problem like 2x times x squared plus 4x plus 7, you would just want to distribute and multiply out the 2x times each of the terms inside the parentheses, and you would get 2x cubed plus 8x squared plus 14x. Do you guys remember doing that? Okay, good. So in this next chapter, what we're going to be doing is sort of reversing that process. So if the problem says to factor out the greatest common factor, essentially the case is going to be that it's going to want you to go from the right-hand side back to the left-hand side, and that would be factoring. So you're taking something that's been multiplied out and you're writing it back as its original factors. So let's try one. We might have something like, oops, I really didn't mean that to be black or red. Let's go back to black. Something like 8x cubed minus 6x squared plus 4x. And so you would look through this and I generally try to look at things, numbers and variables. So my numbers are 8, 6, and 4. And the GCF, or the greatest common factor for those, is the number 2. Remember, a common factor is a number that divides evenly into all of the numbers given. And the greatest common factor for the variables, x cubed, x squared, x, is going to be the lowest power. So the greatest common factor for the variables is x, and then I put those together. My greatest common factor is 2 times x. So when I factor that out, I just think distributive law backward. So I have to ask myself, what would I multiply 2x by to get 8x cubed? And the answer would be 4x squared, since x times x squared would be x cubed. And then the same thing for the next term, minus 3x. 2x times 3x is 6x squared. And then for the last term, plus 2. 2x times 2 is 4x. And on that problem, since it just asked us to factor out the greatest common factor, we are all set. Do you remember doing things like that now, Ashley? Okay, good. So in this chapter, greatest common factor is just one piece of that factoring process. So, and it's usually the first piece. So the first thing we would want to do is factor the greatest common factor. And then what comes next sort of depends on what kind of expression we have. So we're going to divide up the rest of this into sort of a general factoring strategy. And we're going to base that strategy on the number of terms. So we're going to have some processes for factoring binomials, which remember were 2-term expressions. Some processes for factoring trinomials, which were 3-term expressions. And then some processes for factoring more than 3 terms. So we'll just say, I'm actually just going to say more than 3 terms. And in this third case, we will usually use the grouping method. And in the first case, in the binomial case, we will make use of some special factoring rules. The middle case is probably where we'll spend the most time, and we have a couple of choices here. We can either use trial and error, which is problematic sometimes, especially when the numbers are big. So we'll try to avoid that. And the other method we have is called, at least I call it the AC method. How many of you have heard of the AC method before? Anybody remember that? You guys are all getting quiet again. All right, so let's actually start. We're going to start with this grouping method, which might seem strange. We're going to do these in reverse order. So we're going to do 3, 2, 1. So we'll do the more than 3 terms with the grouping method. We'll do trinomials because the AC method requires the grouping method. So those kind of build on each other. And then we'll do the binomial cases, which are really kind of special cases that let us simplify a couple of forms. All right, so a problem you might see might look something like this. Let's go x cubed minus 3x squared plus 6x minus 18. So with factoring by grouping, you usually just sort of pair off your terms and then factor out the greatest common factor. So what I would do on these is I would group maybe the first 2 together and the last 2 together. And it turns out it's kind of interesting. You can usually rearrange and do this in a different grouping order, but you should also be able to go with whatever order they start with, as long as they don't put things together in a funky way. And you just say for each term, you factor out the greatest common factor. So if I look at those first 2 terms, I notice I can factor out an x squared. And when I do that, I'm left with an x minus 3. And similarly, for the last 2 terms, the greatest common factor is 6, and I'm left with an x minus 3. Are you guys with me so far? Give me a yes or a yay or a something in the chat or an out loud yes, so I know you're there. Okay, thanks, Zach and Ashley. So now this is where this is going to go one step further. Notice that I now have a factor in common. Each of my terms has this x minus 3. So that has become a factor in each of my terms. It's a factor in the first term, and then it's a factor in the second term. So to finish this up, I'm now going to factor out that GCF of x minus 3. And when I do that, I have to look at what's left. And what is left is the other stuff. So there's an x squared left there and a 6 there. That is my other factor, x squared plus 6. And it's plus 6 because this was a plus sign. If that had been a minus sign, it would have been x squared minus 6. So I'm factoring out that common factor that shows up after I grouped the terms. Remember, every factoring problem can be checked by multiplying. So if I want to check this, I multiply back out x times x squared, x cubed, x times 6, 6x, minus 3 times x squared, minus 3x squared, and minus 3 times 6, minus 18. And the terms are written in a different order, but that really is x cubed minus 3x squared plus 6x minus 18. Also, remember when you write your final answer, it doesn't matter what order you put your factors in. So if you wrote this as x squared plus 6 times x minus 3, that is also correct. And you're going to get credit either from me on paper or from Alta when you write down that answer as well. So that or that, either one of those are correct. So you group and factor out the greatest common factor in each group, and then factor out the greatest common factor from the whole thing. So let's try another one. I'm gonna have you guys work on this one. Let's try a little borderline there. X squared plus 5x minus 6x minus 30. And I know that my two terms in the middle are like terms, but I purposefully wrote that this way so that we would have 4 terms and we would be able to use this grouping method. So go ahead and try to factor this one by grouping. When you get an answer, just send maybe a yes or something like that to the chat so I know that at least a couple of you have finished the problem, and then we can work through it together to make sure we agree. So has anybody got an answer for me yet? Okay, so you guys are being quiet. Nobody finished yet. Did anybody get an answer? Or are you just not sure enough of yourself that you don't want to say you got an answer? Ashley? Zach? Anything? Anyone? Okay, that's fun. But you have one. Thank you. That's all I wanted, was for you to say you had one. All right. So let's see if you match with what I'm going to get. So I'm going to take the first 2 terms and I'm going to factor out an x. And when I do that, what's left is an x plus 5. Now, this problem was a little bit trickier because I did put in a minus sign on my next term. So I'm going to take my next 2 terms, and since I see that this term is negative, I'm going to factor out a negative 6. That minus sign is going to turn out to be really important. When I factor out a negative 6, I'm left with x. Negative 6 times x is negative 6x plus 5. Remember, when you multiply by a negative, it changes the sign, and when you factor out a negative, it's going to change the sign. Because when I distribute this back through, negative 6 times 5 is negative 30. And now I see my common factor, x plus 5, and my other factor comes from the x minus 6. So I can write down my 2 factors, x plus 5 times x minus 6. And you can multiply that back out and you should get what we had to start with, and you will. Is that what you had for your answer, Ashley? Good. Now, really the only way that things get a little bit more complicated is kind of twofold. One, numbers can get bigger, and I'm going to go threefold. Two, you can have more variables or variables raised to higher powers, and that might make things a little bit more complicated, but we should still be able to handle it the same way. And then the third thing is that sometimes you have to do more than one thing. So you might have a problem where first you need to factor out the greatest common factor, and then you need to factor by grouping. Or first you need to factor out the greatest common factor, and then you have to use some special factoring formula. So just like before, problems don't necessarily get harder, but they probably get a little bit longer as we move through them. But before we do problems that have multiple steps like that, let's just try to get the other types of factoring problems in play. So this was factoring by grouping, and we're going to use that again anyway, so we're going to keep that on our mind. And now we're going to try to factor trinomials. So these are expressions with three terms. And we're going to divide this into two cases. The first case is going to be where the leading coefficient is 1. And then the second case, when we get there, will be where the leading coefficient is something other than 1. So some number other than 1. And that's when we'll go back and use that grouping idea again. So the basic setup here is going to be something like x squared plus 2x minus 8. So the leading coefficient is the coefficient of that highest powered term. And in this case, it's 1 because I just have a plain x squared there. So when I break this down, my plan is to try to write this as a product of two binomials. And so we're just trying to kind of break it up. The reason that we can do this leading coefficient equal 1 case on its own is that we know right off the bat that the only way to break this up and get that x squared is to do x times x. And now I need to find some factors that I can put in here, here, and here, that are going to multiply together to give me negative 8. But they also have to give me the correct middle term. So in the case of the leading coefficient of 1, those numbers have to add up to, or sum to the middle term coefficient. So this is the C value, this is the B value. This works when the leading coefficient is 1, and only when the leading coefficient is 1. Hang on a sec. So when you're coming up with those factors, you need to think about the signs. Notice that the factors are factors of negative 8, which means I'm going to have a positive and a negative. And I want them to add up to the number 2. So I could go through and list all the factors of 8. So negative 8 could be 8 times negative 1. It could be negative 8 times 1. But those add up to 7 and negative 7 respectively. So those aren't the ones I want. Could also be 4 times negative 2 or negative 4 times 2. And those add up to 2 and to negative 2. And we said we wanted 2, so this is the pair that we're going to use. That means back over here, this should be plus 4 and minus 2. And if your leading coefficient is 1, that works every time. So I'm looking for a pair of numbers that multiply together to give me negative 8. and add up to 2. If no such pair exists, if a polynomial cannot be factored, then we say the polynomial is prime. So a prime polynomial is one that cannot be broken down at all. You guys ready to try one? So I shouldn't really call this number 2, should I? Because this was A. We'll call it B, and they make sense. Let's try x squared minus 18x plus 80. So this time you need factors of 80 that add up to negative 18. So give yourself a minute or two and try to think about what those are. I think I'll give you like 60 seconds, see if you guys can come up with them. Zach was fast on there, 8 and 10. And you are pretty much correct, Zach. What do you need to do with the signs on the 8 and the 10? Since they want to add up to negative 18, I need to make them both negative. So now that you've got them, you can go ahead and write down your factors, x minus 8 times x minus 10. And we're all good to go. Again, you can always check every factoring problem by multiplying it back out and making sure that you get the original expression. All right, let's do one more of those. Let's try, we'll switch letters here, but it doesn't really matter. P squared, oops, plus no, 10p plus 25. It's going really slow. All right, so see if you can come up with some factors of 25 that add up to 10. Yes, and notice Zach only gave me one number because it's 5 and 5. So p plus 5 times p plus 5. Or if we wanted to write that in a little bit more concise way, we could write p plus 5 squared. So that's sort of the leading coefficient equals 1 case, which usually isn't too tricky because we can go right from the stated problem to the result. Now, in the next scenario, we're going to look at when the leading coefficient is something other than 1. And this is what's going to take us back to that factoring by grouping idea. So the leading coefficient is something different from 1. And you can do these by trial and error. So if you are one of the few people of those that I've seen over the years who's really good at just sort of guessing what the factors are, please go ahead and use whatever's been working for you. That's fine. But I'm going to show everybody this sort of strategic method that works every time. It might take one more line on your piece of paper, but it will work, and it will tell you when something can't be factored. So here's where we're going to start. We'll start with a problem, and we're going to make the numbers a little bit larger, but not too large. So I'm going to go 6x squared plus 13x plus 6. And remember, my final goal is something like this: two binomials multiplied together. And we're going to call this the AC method. And the reason it's called AC is that we're going to take and use in our quadratic expression these numbers A and C, and we're going to multiply them together. So that's step one. Multiply A by C. In this problem, it's 6 times 6, or 36. Then for the next step, we're going to find factors of that number. And so factors of 36 that add up to the B value. In this case, the B value is 13. So I need to find some factors of 36 that add up to 13. So if they don't jump into your brain, you can just start making a list like we did before. 36 is 1 times 36. Well, those don't add up to 13. 2 times 18, no. 3 times 12, no, but I'm getting closer. I'm at 15. 4 times 9, there we go. Those add up to 13. So once I have them, I'm going to rewrite my middle term using the numbers from step 2. In other words, I'm going to take that middle term and I'm going to write it as 4x plus 9x. And now I have 4 terms in my expression. So now I'm going to finish up by factoring by grouping. So I turned this in from a guess and check problem into a factoring by grouping problem. So my first 2 terms, I can factor out a 2x, and I'm left with a 3x plus 2. My last 2 terms, I can factor out a positive 3, and I'm left with 3x plus 2. And then I have this 3x plus 2 in common. And my other terms are here. So 3x plus 2 times 2x plus 3. And again, it doesn't matter what order you write those 2 factors in when you write your final answer. So we're trying to make use of that whole factoring by grouping idea to aid us in factoring trinomials. So let's try, so this was, let's see, letter A. Let's try one more of those and you guys try to come up with the factors. So I'm going to go with 12 x squared I'm going to cheat because I want to make sure the numbers come out the way I want the numbers to come out. So I'm going to jot something off to the side. Okay, we're going to try 12x, oops, not 12x squared. And I wrote down a different question. We're going to try 18x squared minus 3x minus 10. So you're going to start, remember, with that a times c. So step one, see if I can put a little border here and then have enough room. A times c is 18 times negative 10. And that's negative 180. So this next step just got a little bit more problematic because I have a much bigger number here. I need to find some factors of negative 180 that add up to negative 3. So I'm going to let you guys think about that. I'm going to pause the recording for a minute. Think about what numbers might work. And then when we come back, we'll see if we came up with the same numbers. And then I'm going to show you another way to use your calculator or to use Desmos to help you out. Okay, who thinks they found a pair of numbers that multiply together to give me negative 180 and add up to negative 3? Did anybody find a pair? I'm going to have a positive number and a negative number. I know that much. Because if their product will be negative, I have to have one of each sign. Let's see if we can do this. So we've got negative 180. I could start way up at 1 times something, which is maybe okay, but let's just, oops, get myself back in the right spot. So 1 times 180. And even if one of those is negative, that's not going to work. So I'm just going to keep going. 2 times 90. No. 3 times 60. I'm getting close. Remember, I'm going to pick one negative number and one positive number. So I'm actually going to make the bigger numbers negative since I know I want my sum to be negative. I'm at negative 57. Not even close yet. 4 times something. Does 180 divide into, does 4 divide into 180 evenly? 45. 4 times negative 45. No. 5 times something. 5 times negative 36. I'm getting closer. Those add up to negative 31. 6 times negative 30. No. 7 doesn't divide in evenly. 8 doesn't divide in evenly. 9 times negative 20. That's negative 11. I'm getting closer, but I'm not there yet. So I'm going to kind of go up here. Let's see. 10 times negative 18. Those add up to negative 8. 11, no. 12, yes. 12 times negative 15. And this was probably about as inefficient as I could get, semi-intentional, but there's my pair, 12 and negative 15. So I'm going to go back and rewrite my two terms. My middle term is 2 terms, plus 12x minus 15x minus 10. And then I'm going to factor by grouping. So out of the first pair, I can pull out a 6x, and I'm left with 3x plus 2. Out of the second pair, I can pull out a minus 5, and I'm left with 3x plus 2. So notice again, I have that common factor, and then I have my 6x minus 5. So there's my factor pairs. 6x minus 5 times 3x plus 2. Now notice that that was a lot of work to go through to get those factor pairs and to come up with the ones that work. Okay, so tell me, who here is using, especially Zach and Ashley, because you guys have been asking the most questions. Are you guys using the calculator or are you using Desmos? And it's going to be very similar either way. Calculator or Desmos for your graphing? Cody? Ashley? Ashley's using Desmos. Okay, well, I have this started in Desmos, so I'm going to go ahead and use Desmos. And Zach says calculator. I can show you guys both. I'm going to stop the share from my iPad, so you're going to see nothing for a minute. And then I'm going to share the screen from here, and we're going to go to Desmos. So what I did, I'm going to actually go back here. I graphed y equals 180 over x. So where that came from is, I'm actually going to change this for a minute to show you what I really was after. I'm looking for two numbers who multiply together, and that should have been negative 180. So I've got two numbers that multiply together to give me negative 180. And that's the same thing as saying that one of them, y, is negative 180 over x. I think that if you do this on the app version, you have a little bit simpler method of doing it, but some of the things that are available on the app aren't necessarily available on the website. And then you'll notice what I did is I made a table. So I went to this plus and I added a table. I'm not going to redo it. And in my table, I put my y expression over here. But you'll notice I missed the minus sign. So I'm going to get that minus sign in here. And so now what you can do is you can go through and you can add expressions, add points to the table. So this table doesn't come in automatically. And so what I need to do is I'm just going to keep adding. So when x is 6, y is negative 30. And let's say you didn't know that 7 didn't divide in evenly. You can try it and you'll notice, oh, well, that's not going to work. And 8, yeah, that's not going to work because that's not an integer. There's 9, there's 10, there's 11, there's 12. And there's the one I want, because I want the one where the two numbers add up to negative 3. And so when you get to the pair that you need, you can stop looking and then you know how you want to break that thing down. So that's one way that you can do this in Desmos. On the calculator, see if I can get the calculator up. I'm going to stop that last share. And this time I'm going to share again. I'm just going to share the entire desktop and then I'll find what I want. Oh, shoot. Yeah. Oh, no. Is it making me do this? Okay, I'm going to just continue with the trial version. Okay. So here is a TI-84 starting out nice and fresh. And we're going to do this the same way. So we're going to go to our y equals and we're going to type in negative 180 over x. what is going on here? Negative 180 over, it doesn't like the X from my keyboard, so I have to use the calculator X. And then I'm going to go to the table. So I'm going to go second table. All right, let's do table setup and see what's wrong. So it's going to make me clear, sure, clear the history because that's something's up here. So 1 is to quit. Okay, so table setup. This is going to start my table at 0. I'm going to start my table at 1 just to see if that's where the problem is. And delta table means how the table changes as you go. So I want it to change by 1, so I'm going to leave that alone. Then I'm going to go back to my y equals and make sure that that's in there, minus 180 over x. And then I'm going to go second table. Why won't this make me a table? All right, I'm going to try to type 2 and see where the error is. Oh, this is actually a perfect error because this is something students do quite often, and I don't think I've done it in a while. The minus sign and the negation sign are not interchangeable. That needs to be the little minus sign. So now this should work. Second table. There we go. Yay. Now the nice thing on the TI-84s or similar is that in the table, it just gets generated automatically and you don't have to type anything in. So we can now scroll down through our table and I'm looking for a pair that add to -3. And there it is when I get to x equals 12, y1 equals -15. I found my pair. So then I know which one to use. Okay, so Ashley, does that make sense for Desmos? And Zach, does that make sense for calculator? Even though I goofed up my minus sign at first? Okay, so it's pretty straightforward either way. And so it's just going to be in your y equals. Keep in mind, it's going to be whatever your AC number was divided by x. And that will give you the table that you want. Let that go away. Yeah, I want to let them do that, but I don't want to do that right now. Okay, so yeah, we'll do that later. We'll just scooch that off to the side. Okay, so that's how you would get to that in either Desmos or the calculator, or you could do what I did at first, which was just to sort of make a list until you found the one you wanted. But sometimes that becomes a little problematic when the numbers get even larger. So you could have a problem where, you know, the A value is 24 and the C value is 25. So when you multiply those together, you get 600. And so you're looking for factors of 600 and the list becomes very long. So we want to use technology to help us in a case like that. Do you guys remember doing this at least a little bit from before? Zach says yes. Okay, so we did the 4-term case, we did the 3-term case, and now we're going to look at the 2-term case. And these are going to be some special products. So I am going to, let's see, I'm going to stop my share from my computer. And I'm going to share the whiteboard again over here. And this time we're going to do, where are we? We're going to do the two-term case. And this will be a couple of, actually 3 different special products. And so before we do the factoring case, we're actually going to look at what those special products are. So the first one is going to be what we call a difference of squares. And I think we did an example of one of these last time. This happens when you have 2 binomials multiplied together, where the terms are exactly the same, except for the sign in between. So like an x minus 5 and an x plus 5. When this happens and we multiply this out, we get an x squared plus a 5x minus a 5x minus 25. And those 2 middle terms add up to 0 and cancel each other out. So our net result is just 2 terms. They're subtracted and they are perfect squares. Hence the name, a difference of squares. Now, the way that this works in thinking of this as a special product is that if we do this with any old numbers or expressions, like an a minus b times an a plus b, we get a squared plus ab minus ab minus b squared. And again, those middle terms cancel each other out because we had the plus and the minus, and we get a squared minus b squared. So the difference of squares formula for factoring is just going to be to use that in the reverse direction. If we have a squared minus b squared, then we can factor it as a minus b times a plus b. We just have to identify what those perfect squares are. So for example, if we had 4x squared minus 49, notice that my leading coefficient isn't 1, but it doesn't matter because this is a perfect square. It's 2x times 2x, or the quantity 2x squared. 49 is a perfect square. It's 7 squared. The 2x is my A, the 7 is my B, and this should factor as 2x minus 7 times 2x plus 7. And you can multiply that out and check it and make sure that it works, and it will. So that's sort of the difference of squares idea. Let's try 2 problems for you guys. Let's try, there's no parenthesis yet. Let's try 100x squared minus 81y squared. And then let's also try, let's go with x to the 4th minus 16. So we're going to try to factor those expressions as completely as possible, and they both will be able to use that difference of squares formula. So give those a try. Give me a yes when you either have both answers or you have gone as far as you think you can go and you just want help. Okay, good job on that first one, Ashley. I agree. So I'll go ahead and write that one out. Since 100 is 10 squared we know we want a 10x times a 10x. And since 81 is 9 squared, we know we want a 9y times a 9y. And then we need a minus and a plus in one order or the other, and it doesn't matter which order. You wrote your plus sign first, I wrote my minus sign first, they're both correct. So now go ahead and try that next one. It's a little bit trickier and it's going to involve 2 steps instead of just 1. But you'll start it out the same way. Ashley, how you doing on this one? Yes, very good. It would indeed. So x squared minus 4 times x squared plus 4, because 16 is 4 squared and x to the 4th is x squared squared, or x squared times x squared. So that, yeah, that's right. Now we can go a step further because we see another difference of squares in that first factor. And so that would factor as x minus 2 times x plus 2. And then our original x squared plus 4 just stays as part of our answer. And that's it. And so a short but important note to this, a little footnote, is that a sum of squares like a squared plus b squared, or like that x squared plus 4 that we had at the end of that last problem, is generally going to be prime. In other words, you're not going to be able to factor it any further unless it also happens to be something else. So we'll see that a little later on. If it also happened to be a sum of cubes, you would be able to factor it. But a sum of squares is prime. And to think about why that's the case, if we tried to factor that x squared plus 4, our only options would be an x and an x. And then we could use a variety of numbers to get the 4. We could use 1 and 4, or 2 and 2, or -2 and -2. But no choice, since they have to have the same sign, will allow us to cancel out the middle term. So for example, if I tried +2 and +2, when I multiply out that right-hand side, I get x squared plus 4x plus 4. And there's no way to manage things so that the middle term cancels. So a sum of squares is something that we just can't factor using real numbers. Okay, so now we're going to do one more scenario. And this is factoring for a difference of cubes and factoring for a sum of cubes. And these are a little bit harder to remember. So I recommend writing down these formulas every time you use them so that they sort of get ingrained in your brain a little bit better. They're going to start, as you would expect, with something like an a cubed minus b cubed, an a cubed plus b cubed. The only differences between these two formulas are in the signs. So we're going to write them down together. So in these factorings, you're going to have a binomial, and then you're going to have a trinomial. So 2 terms, then 3 terms. And that shouldn't be surprising because of the cubes. 2 terms, then 3 terms. The first factor is the easy one to remember. It's just the original A and B with the same sign between. A minus B. The second factor, the trinomial, is the harder one to remember. It's going to have an A squared and a B squared, an A squared and a B squared. That part's probably not the hardest part to remember. It kind of makes sense because you would need to multiply A by A squared to get A cubed. And you would need to multiply negative B by B squared to get B cubed. And you would need to multiply B by B squared to get B cubed. So those stay the same. The middle term is a mixed term that causes everything to cancel that we want to get rid of. And it turns out that it's just 1 factor of A and 1 factor of B. And the only difference is the sign on the last one. So same sign, different sign. Same sign, different sign. So that looks kind of weird, but in practice, it's not really too horrible to, as long as you can sort out what A is and what B is, and you don't make any mistakes in squaring, most students do pretty well with these formulas. So let's try one. Let's try x cubed minus 27. So first, notice that 27 is a perfect cube. This really says x cubed minus 3 cubed. So in my formula, every place I see an x or an A, I'm going to replace it with x. Every place I see a B, I'm going to replace it with 3. And so let's see what we get. X minus 3 times x squared, A squared, plus A times B, x times 3, plus B squared, 3 squared. And then a little simplifying, x minus 3 times x squared plus 3x plus 9. And a quick little hint, when you factor these differences of cubes and sums of cubes, this expression is usually prime, which means you're not going to be able to factor it any further. As long as you didn't miss sort of factoring out a common factor to start with, you shouldn't be able to factor that any further when you get done. So it's just a sort of one-step problem if you got all your common factors pulled out. Let's try one more of those, and then I think we'll call it good for today. Let's try a sum of cubes, and this time I'm going to make my numbers a little bit bigger. I'm going to go 8y cubed plus, let's go 125z cubed. So it's definitely a sum, and I'm thinking that it's perfect cubes because I'm seeing the 8, which is 2 times 2 times 2. So that's 2y cubed. And I'm seeing 125, which is 5 cubed. So 5z cubed. So in my formula, my A is going to be 2y, and my B is going to be 5z. So identifying what those A's and B's are to start with is going to get you halfway there, because now I'm ready. I'm going to write down my formula. I mentioned this earlier. This is a sum of cubes. So I'm writing down my sum of cubes formula. And then I'm just going to write everything right below it. So A is 2y plus B is 5z. Now I have to be careful. I need to square A. So I'm taking 2y and I'm squaring it. And then I'm subtracting A times B. 2y times 5z. And then I'm adding B squared, 5z squared. And remember, those parentheses are important because they mean that not only does the variable get squared, but so does the coefficient. So for my final answer, 2y plus 5z, and then 4y squared minus 10yz plus 25z squared. And that's a lot to think about. So I think I'm going to stop recording for today. Or at least we can keep going for now. And if you guys want to hang around and work on problems, you can. But I'm going to stop with my overview and let you guys just kind of work on things, whatever you need to work on. So it might be this, or it might be from something from earlier that you want to pop in with a question about, and you can do that. Does that sound okay? All right, so remember, make sure you watch back, make sure you go in and print out or at least open up and get started on the project so that you can get your work all together and have it done on time. Remember, that project is due on October 25th. So I pushed that back a week so that you have a little bit more time to work on it.